So the first one we'll take a look at, like I said, is the little man computer. This is a hypothetical computer made up by a person named Steve Madnick, I believe, in the 1960s, to try to help people understand what it is that these computers can do. And so I'll start by bringing your attention to a couple of components. So first component here on the right is this group of mailboxes. So in the little man computer, this is an individual who works in a post office, and every day they show up to work, and there are instructions for what they're going to do in their job in these mailboxes here. And so there's 100 total mailboxes. You can see on the left, I've got my sort of number here that marks which is my mailbox, and on the right, I have some value in that mailbox. And we'll explain in a sec what those values are. Okay, so then I've got a calculator in the middle of the room that lets my little man computer perform some very simple stuff. In fact, it really just lets it do two things: add and subtract. And then of course, there's some ways for him to sort of move information from the calculator into a mailbox and vice versa. In the center of the room is, you can already kind of tell this gentleman here, our little man computer, and I'm also drawing a box around this thing at the bottom, which holds the value, the number of the mailbox that we're sort of processing next. So the little man computer is kind of the brain of the operation, this little man in the center, and he's the one that sort of moves numbers to and from places, and this box down here helps him keep track of where he's where he is in the list of mailboxes. So this counter starts at 0, and then after he's completed, the little man computer has completed the instruction that's in location 0. It just increments by 1. So this here is showing us that the little man computer is sort of somewhere on mailbox 5. That's the value that he's kind of working with next. And then off to the left, you see I've got two other really useful parts to my little man computer. I've got an in tray, so the little man computer can take in values, and I've got an out tray for that individual to sort of put values out to the rest of the world. And this little man computer, like I've already kind of alluded, can do just a handful of very specific things. You can see them on the right here. I can do some basic arithmetic stuff. I can do add and subtract. I can, oops. Nope, not the highlighter though. There we go. I can move things to and from memory. So I have a store and a load instruction that let me take values and push values into memory. I have a couple of branch instructions. So this allows my little man computer to do some really complex stuff. It can sort of execute some sequence of instructions and then based on the result, jump to another spot in this list of mailboxes to execute some other instructions. So here, if the number in the mailbox starts with a 6, then this is what we call an unconditional branch. That means automatically jump to another part of the code. If there's a 7 or an 8 in there, these are what is known as conditional branches. So this is, if there's a 7, then the little man computer is going to jump to the instruction listed here only if the value in the calculator is a 0. If there's an 8, then the little man computer will branch only if the value in the calculator is positive. I have two specific instructions that can take something from my in basket and place it into my calculator. That's the input. Or with the output instruction, I can take a value that's in my calculator and send it to this out basket here. And then lastly, I have my halt instruction that'll just tell the little man computer to stop running. What I do to tell this little man computer to perform a function is I sort of arrange these instructions in a specific order that allows the result that I want to occur, and then the little man computer will start executing these things in order via a very specific process that I again kind of alluded to. So the first thing that the the little man computer has to do is fetch the instruction out of memory. The very first thing that happens when this little man computer is turned on is the instruction counter here is numbered at 0, so the little man computer will get the value that's in the 0 mailbox. They'll look at it and they will decode that instruction. That decode means look at that first number and figure out which of these instructions we're trying to execute. In this case, the value is 500. So this would be a load instruction. The third thing the little man computer has to do is execute that instruction. So actually complete what we're trying to do here. If it's an add instruction, then what we're doing is adding a value to our calculator. If it's a load instruction, then we're getting something out of memory and putting it into our calculator. So step 3 is to actually complete that instruction. Step 3 will occasionally have 2 substeps. Number 4 is called access memory, meaning the little man computer might need to get something out of memory in order to complete the instruction. So for an example of that would be the load here. 5xx means take the value that's in mailbox XX and put it into my calculator. 500 is not the most useful because at least where it is right here, because it tells the little man computer get the location in mailbox 00, which is 500, and load that into my calculator. So I'm not quite sure what the usefulness of that would be, but accessing memory, step number 4 in this process, is something I might use for my load. The last step that optionally occurs is called write back to memory. And so in certain cases, the little man computer will have to push a result into one of these mailboxes. And so an example that might be my store instruction. The store instruction says take the value that's in your calculator and store it back into the mailboxes at the value XX. So for instance, if my computer was set up like this with 1, 2, 3, and my little man computer were executing the instruction 398, that would be a store the value to memory 98. So down here in memory 98, I would get a 1, 2, 3. So here's how this might kind of operate. Let's take a look at a sample program here. Let's say I'm trying to find the maximum value between two values that are put in my input, an X and a Y. I'm gonna change our perspective just a little bit. This is a little worksheet for the little man computer that gives me a bit more room to work with in the mailboxes. So we can actually kind of write out a program. So to start with, I'm going to assume, like at some point the user is going to type a first number, kind of put that in the inbox. So first thing I need to do is get that out of the inbox and place it into my calculator. So the instruction to do that is a 901. That's my input instruction. And I'm going to add a little box down here for my my calculator. I'll call it my accumulator. So that's going to get the value 5. The user's going to give me a second number. I don't want to forget this one, so I need to store this number somewhere safe. I'm going to use the store instruction, which starts with a 3, and I'm just going to pick an arbitrary box here. We'll call it mailbox 30. So 330 is where that value is going to get stored when that instruction gets executed. The value that's in my calculator or my accumulator here is going to get stored in memory location 30. Okay, so now let's assume the user's put in the value 4 into my inbox. I need to get that number, so I'm going to issue another input instruction, 901. That's going to put the value 4 here into my accumulator. And then I also want to save that value. So I'm going to choose the next mailbox down, 331. That's going to store the value here, 4, into this mailbox. So I've got 2 values. I got them stored. The second one is here in my accumulator. In order to figure out which one is larger, the simplest thing to do is to subtract one from the other and test if the result is positive. So what I'm going to do is issue my subtract instruction. And the thing that I want to subtract from my accumulator is the first number. Since this is the second number is in there, I'll subtract the first number. The first number is in this mailbox. So 230 will tell the little man computer, take the value in your accumulator, in this case 4, subtract the value in mailbox 30, in this case 5. The result is going to be -1. Now what I can do is change what this program does based on whether the value in the accumulator is positive or not. If it's positive, then that means the first result is smaller. If it's 0 or negative, Well, if it's negative, then we know that the value in the second box is smaller. So I'm going to issue my jump if positive instruction. So I'm going to issue this jump if positive. I need to go somewhere else in code. Right now, I'm going to pick kind of arbitrarily this mailbox 20. This will be the spot where I execute some additional code. Or I'll choose mailbox 10. I'll execute some additional code here if the value in the accumulator is positive. So I'll say if it's positive, jump here. In this case, it's not. So what I want to print to my output is the larger of the two numbers. If I get to mailbox 6, then I know the value in my accumulator was not positive. That means the larger value is in mailbox 30. So what I can do is load that value into my calculator. And then lastly, put that value onto the output 902. So this works as long as the first number was positive. Let's try this one more time and to see what happens if the numbers are reversed, and I want to send my other value to the output. So I'm going to get a value first. Let's say it's 4330 says store that number in mailbox 30. I'm going to get the second number, which is 5 in this case, so that comes into my accumulator. I'm going to store that value in mailbox 31. Then I'm going to subtract. I get the value 1 because 5 minus 4 is 1. Here now I get to mailbox 5. Branch if positive says if the accumulator is positive, which it is, branch to line 10. Okay, so now if I'm in mailbox 10, then I know the value in mailbox 31 is larger. So instead of loading 30, I'm going to load 31. That'll put the value 5 back in my accumulator, and then I can send that to my output. So in both cases, I get the larger of the two numbers via this sequence of instructions, this sequence of numbers that commands my little man computer and tells it what to do. Okay, so this, like I said, is a very, very simple computer, but it already illustrates a couple of really key things about our computer. The first thing it illustrates is each of our components. So our mailboxes here represent something called memory, which is where we are able to store not just data that we want to operate on, but also instructions that are encoded using numbers. We'll talk about that more later on. But this here is my memory. A really key component in the middle was my control. My little man computer was controlling, orchestrating the whole thing, and that's a very critical component. They were moving values from memory to the calculator, and so this part up here we call the data path, is the movement of values from memory to be operated on here in our calculator and then pushed back to memory. The in tray represented my input. In this case, it was just a number, but input for any other computer could also be, you know, a mouse or a keyboard or something like that. The out basket was my output, and so that represents, you know, any sort of output on my computer, my speakers, my monitor, that sort of stuff. So here I've got 5 components that make up basically every computer. And there's one more distinction we make, which is that the control and the data path together are so integrated that sometimes we call them the processor. All right, so these are the five basic components of a computer: memory, control, and data path, which are sometimes together called the processor, and I've got some input and some output. And then the little man computer also demonstrates these 5 steps that occur over and over again in its processing of each instruction. These are this set of steps is called the instruction cycle, or as I specified in the start of the video, it's also called the von Neumann instruction cycle: fetch, decode, execute, potentially access memory. I'll put a little asterisk to say that's kind of optional, and write back to memory.